Well, good afternoon. This is 2:15 on, I think it's Monday, the 15th of November. I believe that's correct. 2017. It's supposed to be time for differential equations. However, I'm the only one in the room. Sorry, we're a little late getting started because a student from my last class had a question that I had to look up some stuff for her. And then by the time I finished doing all that and going out in the hall to get a drink of water, we only had 5 minutes between classes. I was late getting back in here. Sorry about that. Just a couple of announcements. I hope you realize this, because I know some of you are transient students and you may not be realize what our schedule is here, but we have the whole week off next week. Okay, you have the whole week off. We don't. We have professional development days, Monday, Tuesday, and Wednesday, but you have no classes at all next week here at Lawson. If you're at Alabama or somewhere else, you may have classes, but not here. The two-year college system, the Alabama Community College Association, has its annual meetings the Sunday, Monday, and Tuesday of Thanksgiving week. And they allow Wednesday as a travel day for people to get back home, I think, or something like that. But anyway, the meetings are down in Montgomery, and they start, I think, Sunday afternoon of next week, and they continue through Tuesday, I think around noonish. So I think everybody has a chance to get home by Tuesday night, but that may allow people some extra time from traveling and stuff like this. So, schools do whatever they want to on Wednesday. We have, those of us not going on the professional meetings, we have professional meetings here on campus. It'll be on the Birmingham campus, not here on Bessemer. So that'll be Monday and Tuesday. Then Wednesday, we're back in our offices. For me, it'll be here on the Bessemer campus, and I'll be here then. So, long story short, if you need to talk with an instructor, an advisor, or anybody such as that, be sure you check with them beforehand to see if they're going to be, where they're going to be. Like I said, our meetings are usually on the Birmingham campus, so you don't come looking for us here Monday or Tuesday. The odds are we won't be here Monday or Tuesday. We'll be on Birmingham campus. Wednesday, we'll be back in our offices, so look for us in our offices. However, some people will take personal leave, and some people may be down in Montgomery. So don't make an assumption that you're going to find somebody. Check with them first and make an appointment, make sure that you know where they're going to be, when they're going to be there, and that you don't wind up making a special trip for nothing. Now, all of the offices, if it's something to do with the business office, any other offices on campus, those offices generally will be open. They won't be fully staffed because some of those folks are down in Montgomery as well, and some may be taking personal leave for Thanksgiving. So expect to find short staffs, but there will be people open. The offices will be open generally just 8 to 5, I think, or maybe even shorter hours than that. Except for maybe Wednesday afternoon. Don't expect to find too many people here Wednesday afternoon. Typically, I think the administration usually sends out the word that people can go home sometime in the afternoon. It may be noon, it may be 2, it may be something else like that, but don't expect to find everybody here on Wednesday afternoon. Okay. Sorry, I was just making this announcement. I'll make it again because you probably not go back and listen to this. We don't have classes next week at all. I don't know if you're aware of that, right? The two-year college system, the Alabama Community College Association, has its annual meetings on Sunday, Monday, and Tuesday of Thanksgiving week. And because a lot of people go to that, they make that professional duty days for us, which gives you the time off. We'll be here. We'll be somewhere. I will be on the Birmingham campus Monday and Tuesday of next week, and here on this campus on Wednesday of next week. Um, but there won't be classes. We have professional meetings Monday and Tuesday. Some people will be down in Montgomery. That's where the ACCA meetings are, and they'll be there. Those that don't have chosen not to go to those meetings will have professional development on the Birmingham campus Monday and Tuesday. Wednesday, they let us come back to our offices and take care, do office work. So if you do need to see me next week, I'll be on Birmingham campus Monday and Tuesday, here on this campus on Wednesday. But Monday and Tuesday, I'll be in meetings most of the day. I don't know what hours now, but most of the day. Wednesday, I'll be here. But I was just saying, typically on Wednesdays, they sometimes let people go home early because it's the day before Thanksgiving. Yeah. So don't expect to find many offices open much afternoon. I think last year they let us go at 2. Okay, so, but I can't say when it'll be this year. So if they even let us go early, but don't expect there to be too many people around. And people will take personal leave too. If they need to go home and start cooking, they need to go home and start cooking. So they'll take personal leave or vacation or whatever. Okay, so that was one announcement. Another announcement, usually I have office hours on Friday, 7:45 to 11:45 on the Birmingham campus. This Friday, I don't know if that's going to be true. One of my other students, a student from another class, said I was saying I need to get my car tag for my new vehicle. I took my tag off the old vehicle, but I found out they needed a bill of sales, and the people didn't give me one when I sold the old vehicle. So they emailed me one, but I couldn't deal with it until Friday, but Friday of last week was a holiday, so the offices were open. Well, the same thing with this week. I can't deal with it until Friday, so Friday I'm going to try to go first thing in the morning to the courthouse and hope to be there before 8, so I'll be near the first of the line. So hopefully I can get the car tag done pretty easily. But if I can't, I don't know what time I'll be on campus. Now, if I found out they don't open DMV until 10 o'clock or something like that, I'll come to campus and then go and do it afternoon and stand in line. But the student said she thought they opened at 8. So I will try to be there before 8 and get it done and then get to campus as soon as possible. I don't think I'll be on campus. I don't think it'll be possible to be there before 9. So I'm guessing around 10. So my office hours this Friday will be something like 10 till 2 or something like that. Okay. All right, any questions on anything we've done so far? Okay, sorry we're late getting started, but a student from my last class had a question. I had to go over stuff with her. Then I had to do some research and find some information for her. And when I finally got that done, I only had 5 minutes between classes to begin with. It was already about 10 minutes over, so I got me some water and something to drink and went by the restroom and then came back, so I was late getting started. Then I made the announcements, and then I made them twice. Okay. So I think we're starting today in section 4.2. It's called reduction in order. In the preceding sections, any questions on anything before this? No. Okay. By the way, I've gotten a paper in for you for this class and your first test. And you have your second test already, right? Yes. Okay. All right. So make sure that's where it was. Okay. So the preceding section, we saw the general solution of the homogeneous, linear second order differential equation. And this is just going to be second order. Okay. A2x, and that 2 is just a marker saying this is the coefficient function for the term that has the second derivative, y, second derivative of y, plus a sub 1 of x, and that 1 there is just saying this is the coefficient function for the first derivative of y, okay, plus a sub 0 of x. This is just indicating this is the function. The 0th order derivative, meaning just the function itself, y is equal to 0. Okay? That's a second order. Oh! Yeah, I was trying to get your attention, but. Okay. Yeah, when those students are in, I don't turn on the projector until students come in, and I got talking with you and I forgot Okay. And if it's too cool in here, I can close the window. But it has been just almost unbearably stuffy earlier, and I finally opened the window because it was. I don't know what the rationale of this, the way they run the buildings here. In the summertime, or in warm weather, when they have the AC on, they have the thermostat set for 68. So when you're wearing the lightest clothing, because it's warm outside, they have it cold in here. And then when it gets cold outside, they run the thermostat at 72 or higher. And that means you're dressed for warm weather. For cold weather, you come in and you're sweltering, okay? And it's wasteful and energy-wise. You're cooling more than you need to cool, and you're heating more than you need to heat. Why don't they keep it just at, either 71 or let it fluctuate, like 72 in the summer and 68 in the winter? That would make more sense than what they're doing now. And I'm going to try to complain because they did it last year too, I noticed. I thought, why are they doing this? Okay. So anything, here is your standard second order differential equation, linear differential equation, homogeneous, meaning is equal to 0. Okay? And in the preceding section, we saw that the general solution for that is a linear combination of y is equal to c1, y1 plus c2, y2. Okay? Now, you'll need to have two solutions because this is a second order equation. If it was a sixth order equation, you need 6 of these. And then the c's are arbitrary coefficients that could be anything. If y1 is a solution to that and y2 is a solution to that, then the c's are arbitrary. Now, if that was an initial value problem that you had two conditions that are met, then you can solve for the two c's and you have a unique solution. But the general case, when you don't have an initial value or even a boundary value, then these will be. Now, I'm getting chilled a little bit. I'm going to close the window. In the last class, it did absolutely no good having this window open. I think what the strain was, there was not much wind outside. There's not a lot of wind now, but definitely something picked up or else it's blowing in something that's making me sneeze. We'll see if this, I don't know. I'll just try to play it by ear. Okay. And by the way, the y1 and y2 have to be linearly independent of each other. There's the infinite number of solutions probably there, but you need to express these as a linear combination of linearly independent solutions. Now that would be defined on some interval I. I forgot to mention that. Now, beginning in the next section, we examine the method for determining these solutions when the coefficients of the differential equations are constants. That's going to be 4.3. Okay, not yet. This method, which is a straightforward exercise in algebra, breaks down in a few cases and yields only a single solution, y1, of this differential equation. It turns out that we can construct a second equation, solution y2, of a homogeneous equation like this, even when the coefficients are when the coefficients in this equation are variable, provided that we know the non-trivial solution y1 of the differential equation. The basic idea described in this section is that equation 1, this equation right here, can be reduced to a linear first-order differential equation by means of a substitution involved with a solution y1. The second solution y2 is, oh goodness, my nose, is apparent after the first-order equation is solved. This is called reduction of order. Okay? Now, suppose that y1 denotes a non-trivial solution of that differential equation. We not want, you know one of them, y1. Okay? We seek a second solution, y2, so that the set consisting of y1 and y2 is linearly independent on the interval, I. Recall from section 4.1, if y1 and y2 are linearly independent, then their quotient, y1 divided by y2, is a non-constant on the interval. In other words, y1 and y2, if they're linearly independent of each other, they can't be a multiple of each other. If they're a multiple of each other, they'd be dependent, okay? And if they're multiple of each other, then the ratio would be a constant, either a fraction or a whole number, okay? So they're a non-constant, okay? So let's just assume that that ratio, and they're going to do it as y2 of x to y1 of x, is some other constant, some other function u1 of x. So they just may call it u of x. Yeah, let's just call it u of x. Okay? It's not a constant. It's some function of x. Okay? What does that mean? That means multiply both sides by y1 and you get y2 of x is equal to u of x times y1 of x. Or they may have written in the other order. No, that's how they did it. Okay? The function u of x can be found by substituting the y2 equal u of x times y1 of x into the given differential equation, and that method is called the reduction of order because we must solve a linear first order differential equation to find u. Okay? So, blah, 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 let's look at an example. Okay. Given that, and this sort of bugs me, y1 is equal to e to the x. Okay? And they tell you that's the solution of this differential equation. Y double prime minus y prime is equal to 0. Okay? On the interval minus infinity to infinity. Okay? Now, I think you can see that's true. Because what's the first derivative of y1? Okay, second derivative. So you have e to the x minus e to the x, that's 0 everywhere, right? Good for all real numbers x. Okay? So yeah, that certainly fits. Okay? Well, is there any other function linearly independent of that that also works? Okay? Is there a y2? Well, the technique is to let y2 equal, and this is a function of x, equal some u of x times y1 of x. Okay? So in other words, y2 of x is equal to e to the x u of x. Okay? Right? Yeah. Okay. Let's plug that into our differential equation. Well, let's take a derivative. Okay? y2 prime would then be product rule, right? What would that be? U of x, that's fine.
Times the
Derivative of e, which is e to the x plus
derivative of u of x.
U prime of x e to the x. Okay. All right, let's do y2 double prime. And what would that be? U to the x, u of x, I'm sorry.
U of x times
E to the x
plus u double prime of x.
Okay. All right. Are you taking a derivative of the first term Let's do the
Yeah.
complete product rule for that. Okay?
Oh, I'm sorry.
Yeah, yeah.
I see what you're saying. Yeah. I'm so sorry.
Otherwise, we may forget it. So,
You primary.
okay, e to the x. Okay, so that's the derivative of the first one.
Yeah.
I'll take the derivative of the second.
Now the second one is going to be u prime of x times e to the x.
Okay,
Plus, u double prime of x times e to the x.
okay. All right. And let's simplify that. We got these two terms are identical. That'd be u of x e to the x plus 2u prime of x e to the x plus u double prime of x e to the x. I can't write. Let's factor out the e to the x, and you have u of x plus 2u prime of x plus u double prime of x. Okay. Now, let's take these two and enter them up there. I don't have much room. Okay. And that would be e to the x times, I'm going to reverse the order here if that's okay. U double prime of x plus 2u prime of x plus u of x minus e y prime would be u of x, e of x. And by the way, you can factor out e of x there too, so let's get those out of there. Minus u of x, no, minus, because it's still, yeah, this minus here goes across both of, yeah, u prime of x. Okay, and supposedly this is equal to 0. Okay. Now, here, this one wipes out one of those. These you lose completely. Okay? And that gives you a u prime of x minus u double prime of x minus u prime of x is equal to 0. All right. They didn't lose one. What's wrong with them?
Then we got like 2u prime of x.
They have a 2u prime. I only have a u prime. I don't see where they get two of them.
Yeah, you got it on there. It says 2u prime, I believe.
What's that?
At the very bottom, I think it says 2u prime.
Yeah, well, it was, but you see, I subtracted off the u prime from this one. So it was, and I mean, it's exactly what they've got here. Y prime was u u e to the x plus u u prime e to the x. Okay, y double prime, and they leave off the x's. That makes it a lot easier. What we had here, u e to the x plus 2 e to the x u prime plus e to the x times u double prime. Okay? Now, when they do y2 minus y double prime minus y prime, they have e to the x. They factor that out just like we did. Mm-hmm. And then they have u double prime, which is what we do.
Yeah, got it.
And then when they subtract, they still have a 2 here. And when you subtract this one from this one, that leaves you only 1.
Yeah.
And so I think ours is right and theirs is wrong. And e to the x can't be 0. So eliminate that. That gives you u prime. And they say u double prime plus 2u prime is equal to 0. I don't see where they get the 2. I mean, you subtract the 1 away, and that left you just 1. So I don't know how they got that. If we make the substitution w is equal to u prime, that linear second order differential equation, this is second order, make w equal u prime, so this becomes a w, that becomes a w prime, and that becomes a linear, a first order differential equation. Okay?
You said that they still had 2u prime?
Yeah, they still have a 2u prime. Okay. And then they make a substitution. Now, see that. And then they do an integrating factor. I cannot follow how they, it looks like they just started from a wrong assumption, and then they just go haywire trying to correct themselves on it. And I think if you just did it right, then you would get the correct answer. And they didn't. They got it wrong, and they go through all sorts of gyrations. Let's continue what we were doing. I think it'll work for us. This becomes our equation. U double prime plus u prime is equal to 0, right?
Oh, you add in e to the x.
Yeah, well, because e to the x can't be 0.
Yeah.
Right. So it's got to be this part. So I'm going to go up here and erase what I can. Okay. I don't think I need this part anymore. I will keep that first part, but not the second part. Okay. And we're going to wind up with exactly the right answer without their really confusing, contortions they go through to make the answer come out right. And this one, it just comes out easily to be correct. Okay? So what we wind up with is u double prime plus u prime is equal to 0. Okay? Now, I'm sorry, I hit the wrong button. Now, this did this some last week. It just refuses to change. Okay? Let me try this. Sometimes Control-Alt-Delete starts a task manager. Let's see if something fell apart. No, everything's still running. So I'm just going to end the task. Oh, that's not what I wanted to do. I may have just messed something up. All right, now I'm back. I hope I'm back. Huh? Sorry about this. And now I have to go through this. You can't see what it's doing. There's no disk drive in D, which there's not supposed to be, and it just keeps me saying there's no disk drive in it. Please insert a disk. I don't need a disk. And I just have to keep that. Okay, thank you very much. Okay. We're back. Okay, sorry that we lost what we had, but what we had was u double prime plus u prime is equal to 0. Remember? Okay. Now, what they suggest doing, let w equal u prime, right? Then u double prime is equal to w prime. So this becomes w prime plus w is equal to 0. Right? Now, okay, so this is, okay, I won't do this. Now last time I went to eraser, it whacked out. Let's see if it'll, yeah, it's coming back this time. Okay. Okay. Based on what we did last time, I think we can just imagine, well, let's rewrite this as d w dx plus w is equal to 0, right? So let's make this as dw dx is equal to minus w, okay? And make that as dw over w is equal to minus dx, right? I'm separating variables. Subtract this from both sides and we get this.
Yeah.
Divide by this and multiply by that. Keep the minus sign over here. Let's integrate both sides, and what do we get? What's that?
I guess a constant.
What? dw, integral of dw over w?
Yeah.
What's that?
Why not just be w or dw?
Log w.
Huh?
Log w. ln.
Oh, yeah, it is.
Minus x. Right?
Yeah.
Right?
Yeah.
Okay? So then take the e of both sides, and you get w is equal to e to the minus x. Now, it took them this much room of going through. I swear, what they did was crazy. And yet they wound up getting that, e to the minus x. This way you get it directly. I mean, there's no ambiguity here. W is equal to e to the minus x. Okay? Did I do that right? Should I go back? No, I probably should have done u first. Okay?
Why did we change it to W? Why we just didn't keep it U?
Huh?
Why did we change it to W? Why we just didn't keep it U?
Just to get it down to linear, to a first order rather than a second order. That's what they were doing. And anyway, so you get this. So here's the other one. And I'm not going through what they did. So your y2 is equal to e to the minus x. Okay? So now we have our general solution. Y is equal to c1 e to the x plus c2 e to the minus x. Okay? And there's your general solution. That to me is a far cleaner way of doing it than the way they did. The way they did was just absolutely ludicrous because they messed up and had it the wrong number to begin with. That wasn't a 2, it's a 1. And they went all sorts of tricks that I don't know if they were all justified to get them to come out. But anyway, that to me is the better way to do it. Now that's reduction of order. The next thing they're going to hit is what they call the general case. Okay? So let's erase all of this. And it says, suppose we divide by a2 to put the equation in standard form. So in other words, let's go back to our original equation. a2 of x, y double prime, plus a1 of x, y prime, plus a0 of x, y is equal to 0. That was our original equation. Let's divide everything by a2 of x. Now here the assumption is a2 cannot equal 0 anywhere on the interval. Okay? Well, that makes sense, doesn't it? Because if a2 was 0, you wouldn't have a second order differential equation. You'd have a first order differential equation. So we're safe in doing that, so now we can divide by a2. And we'll divide this by a2 of x, and divide this by a2 of x, and we'll even divide this by a2 of x, but that's still 0. Okay? So what we have now is y double prime plus, now, let's just change that rational expression, a1 of x divided by a2 of x, to some p of x. Y prime plus, and let's change the a0 of x divided by a2 of x is some function of x. Let's call that your q of x. Y, and that's still 0, right? Well, that's our standard form for a linear differential equation, isn't it? Okay, remember way back when we did that? And then we did the integrating factor and all that kind of stuff? Okay, so that's what we're going to do here too, where p of x and q of x are continuous on some interval x. Interval I. Okay, now for them to be continuous, that means we divided by a2 of x here. And for both of these to be continuous, obviously, well, we already said a2 can't be 0. So if you factored it, neither one of the factors could be 0. And that would be the only thing that would keep them from being discontinuous, right? So they're going to be okay, I think. Okay? Continuous everywhere. And we'll just pick intervals that it would be continuous. So p of x, q of x, continuous on the interval I, whatever that is. Let's further suppose that y1 of x, one of your solutions, y1 of x, is a known solution of that on I, okay? And that it's not equal to 0 for every x in the interval. So it's not a trivial solution, okay? And not equal to 0, okay? It can be for some values, but not for everyone, okay? If we define, this goes back to what we're just doing, y is equal to u to the x, y1 of x, okay? It follows that let's take a derivative here. Y prime is equal to, what would that be? U of x y1 prime, okay,
plus
u prime of x, not prime, y1, yeah, okay, perfect, okay. And let's do it a second time. Y double prime would then be
u of x times y1 double prime of x
right,
plus u prime of x times y prime of x, and then plus u double prime of x times y1 of x.
yeah, I'll put on one there,
Plus u prime of x times y1 prime of x.
okay. Now, if you'll notice here, you got two of these terms. Okay, so we can simplify that to be I'm going to leave off the x's here. uy1 double prime plus 2 u prime y1 prime plus u double prime y1. Okay. That's your y double prime. Okay. Now, all right. Now we're going to plug things back in, okay, up here. I think I'll take this line out because it's sort of an obvious line and we're not going to use it right away, if at all. So let's take that out and fill in what we have. The y double prime here was u y1 double prime plus 2u prime y1 prime plus u double prime y1 plus, now my p of x. Just leave it p. I'm going to leave off the x's. y1 prime plus q y1 equals 0. Right? That's what we get for when we plug in. Oh, wait, sorry. I didn't quite do that right. All right. Got a little carried away too soon. All right. P, and your y prime was this one. y1 u plus u prime y1. Okay. plus q y. But y is y1u. Okay. And that's equal to 0. Okay. So what we did, we plugged in y is equal to u of x, y prime of y1 of x. So then we did all these things. So when we plug this back in, goodness, that's amazing. So we did this one, which is this, okay, plus p times this one, which is, I did there, okay, plus q times this, okay, which I did there. All right. Now I'm going to group terms, okay. I think I hope I can erase this. I hit the wrong key. Okay, this one. All right. Now, remember y1 was a solution. So u times y1 double prime plus p y1 prime, that's this one and that one, plus q y1, yeah, that's this one, factoring out the u, okay. Okay, that's this term, and that term. All right, and what do we have left? 2u prime y1 prime plus u double prime y1 plus p u prime y1 is equal to 0. Okay? Right? I just rearranged terms. I pulled this one, and that one out here. They each have a u in it, not prime, just u. And then this at a y1 prime, this is a double prime y1 prime, and that has a y1. Okay? And I'll help the sign here. That's a plus here. Okay. And then I wrote the rest of them that I didn't pull out. 2u prime y1 plus u double prime y1 plus u prime y1 pu prime y1, okay, is equal to 0. But this thing right here, remember we said y1 was the solution to this. Now I'm afraid I already erased that. If y1 was the solution to it, this thing right here is 0, right? So this thing is 0. So that leaves us just this. And this has just y1 in it, okay? No, that y1 is prime, isn't it? Yeah, that one is prime, okay? But now we've reduced an order. We're down to a y prime 1, well, okay. All right. Let me not get too far ahead, okay? Now, I think we're okay here. I hope you can remember that y is equal to u times y1. We're going to use that probably again later, but let's get this out of the way now so I'll write down what's left. Okay? this was all equal to 0. Okay, so that can come out. So what we have left is, I'm going to get the U's in order here. U double prime times Y1 plus 2U plus PU prime times U prime. U double prime here, 2, I'm sorry, that's a Y1 there, sorry. Okay. The 2, I'm pulling out the Y prime, U prime, so it's 2Y1 prime. So it's U double prime Y1 plus 2Y1 prime plus PU. This is a Y1 prime. Y1 prime. U prime is equal to 0. Okay. Now, sort of taking a look at this, again, we've dropped, if we put a U prime equal W, we've reduced this to a first order differential equation, whereas that started with second order differential equation. Okay? So let's see, Y1 U double prime plus 2Y1 prime plus PY1. This is not a prime here. There's a Y1. I'll put my prime up there. Okay. PY1. That's not a, okay. U prime is equal to 0. Okay? Now, if you make the substitution, so I'm going to erase what I got here. I hope I won't need this again, but if I do, I know where to look it back up. Okay? And I think I might as well go and get rid of all this, because I've gotten rid of all this built on the other, so if I got rid of the other, that doesn't do any good for me to have this. I hope. I'll go back and find it if I need it. Okay. So again, we're going to let, ugly L, let W equal U prime. So then W prime is equal to U double prime. So what we have here is W prime Y1 plus 2Y1 prime plus PY1 times W is equal to 0. Okay. And that's their equation for Y prime, W prime Y1 plus 2Y1 prime plus PY1, W is equal to 0. Okay? And that's linear inseparable, just like we had before. So let's do that. W prime Y1 is equal to a minus 2Y1 prime plus PY1, and then divide both sides here by Y1. Oh, and this had a W here, I forgot that. Yeah, okay. And divide this by Y1, divide this by W, and divide that by W. These go out here, These go out here. And we have y prime over, w prime over w is equal to minus 2y1 prime. Goodness gracious, I can't write. Okay. Oh, man, my head. Minus 2y1 prime plus py1 over y1. Okay. Okay. Now, I have a feeling I should have divided the other way. W divided by W prime, and that thing divided, y1 divided by that prime. Yeah, it should be dW over W. No, we got it right. Yeah, I had it right. So,
Now you like integrated or something?
yeah. You're right, this is dW over W. So basically, I still can't write. I say W and it looks like a D. Okay. Now, when you do this one, you'll have a minus 2y That's right, this is a dy over y. This is, I say y and write w. Goodness gracious, this is driving me nuts. Okay. dy1 over y1 plus, and here you see the y1s will cancel out. Actually, that's a minus p. Okay? And you integrate that with respect to x, okay? What's that?
How you integrate it to respect to x?
Yeah, because y is a function of x.
Okay.
Okay? This just comes out log of w.
Yeah.
Okay? And this comes out log of y1, and this is just some function of x. So when you integrate that with respect to x, you have to integrate that, whatever that is. Okay. Now, yes, I think I can erase my top line. Again, if we need it, we can reproduce it easily. This is one problem of having such a small screen. And if you think I might be writing too big there, I'm writing really small on this little screen. It's just getting projected to look big. I can't write much smaller and read what I've got, so I'm stuck with it. So this gives us, when you integrate this is log w is equal to a minus 2 log y1, okay? And you integrate that, and you have minus p. I'm going to go back and put p of x times x, okay? And then you probably have a plus c or something out there, but we're not going to worry about that too much to begin with. The first thing we're going to do is add this log to both sides. But 2 log y1 is the same as log y1 squared. Yeah. Said it right again and wrote something wrong. Okay. Let's see if I can get this right this time. That's what I'm trying to do if I can ever get it right correctly. But you see, I added that here, but 2 log y1 is the same as log of y1 squared. Remember, that's the rule of logarithms.
Yeah.
Right. Okay, so that's what I added to that side. So now you got the sum of 2 logs. Well, that's the log of their products. So this becomes the log of the absolute value of w y1 squared. Okay, this goes away, and this is equal to, when you integrate that, they leave it just minus the integral of p of x dx. Now, I think that was supposed to be a d up there, and I just missed it. Okay, integral of p of x dx. Okay. Now, I hate to erase this one because I think we're going to need it again, but remember this line. That was our standard form for the linear differential equation, right? Y double prime p of x, y prime q of x, y is equal to 0. Okay? Remember that. And what did we do to it? I think I can erase all this. I hope so, because I'm tired of erasing one line at a time. Okay. I haven't dropped anything somewhere that I can't find again. But I think we're out of time.
Yeah, we are.
I'm sorry. But here's the point. If you do an E of both sides, I'll erase my white there. Okay. Oops. Okay. When I was erasing the line below it, call that. If you take E of both sides, you have w y1 squared is equal to e to the minus px. Remember that? That's our integrating factor. E to the minus integral of px dx. Remember that way back?
Yeah, yeah.
That's exactly how we got it, by doing this. So we wound up with that same integrating factor we did before. And remember, that was exactly the function we had before, only this time it's not some, I think that we use the thing you know, it's a wy1 squared, okay? But I think if you went back and did it, you'd find out that comes awfully close to being u anyway. We'll pick up from there. We left off at that term right there. So I'll pick up here, and we'll go from there next time. Let's see if we got enough done that you can do any home. Oh, this is a very short section. We should have finished it today. Try to do some of the odds 1 through 15. You may not be able to do all the more difficult ones. See if you can do at least 1 or 2 of those. And we should be through with reduction of order very quickly. Sorry that took too long.